Hello, with math is easy with Ala. Today our tutorial will be trigonometric substitution x equal a sine theta. Let's start our tutorial. In the right triangle, if angle theta is here, suppose the opposite side of theta equal x and the hypotenuse is a. By using the Pythagorean theorem, we can find the adjacent equal the square root of a squared minus x squared. To find sine theta equal the opposite over the hypotenuse, and the opposite is x and the hypotenuse is a. So sine theta equal x over a. To get x equal a sine theta. Now in the expression square root of a squared minus x squared, the trigonometric substitution will be x equal a sine theta, and theta belong to the interval minus pi over 2 to pi over 2, and the identity will be cosine squared theta equal 1 minus sine squared theta. How can we use this in antiderivative? Let us take this example. Find the antiderivative of 1 over cosine squared square root of 4 minus x squared dx. Now notice that the square root of 4 minus x squared is in the form square root of a squared minus x squared. This means that a squared equal 4, for that a equal 2. We can use now the substitution x equal a sine theta and x equal 2 sine theta because a equal 2. Now our strategy will be remove all reference of x to reference of theta. Now if x equal 2 sine theta, then dx equal 2 cosine theta d theta, and x squared will be 2 sine theta squared, means that x squared equal 4 sine squared theta. Now substitute x squared by 4 sine squared theta and dx by 2 cosine theta d theta. We will replace x squared theta here by 4 sine squared theta, and also x squared here by 4 sine squared theta, and dx by 2 cosine theta d theta. We will get now the antiderivative of 2 cosine theta over 4 sine squared theta square root of 4 minus 4 sine squared theta d theta. Now we will get 4 inside the square root as a common factor. We will find that the antiderivative 2 cosine theta over 4 sine squared theta square root of 4 times 1 minus sine squared theta d theta. Now we notice that 1 sine squared theta equal cosine squared theta. We will replace 1 minus sine squared theta by cosine squared theta. It will be the antiderivative of 2 cosine theta over 4 sine squared theta square root of 4 cosine squared theta d theta. Now the square root of 4 cosine squared theta equal 2 cosine theta, and it's positive because theta belong to the interval minus pi over 2 to pi over 2, and in this interval cosine theta is always positive. For that we will now simplify 2 cosine theta with 2 cosine theta, cancel 2 cosine theta with 2 cosine theta. We will get the antiderivative of 1 over 4 sine squared theta d theta. Now sine theta reciprocal to cosecant theta. If cosecant theta equal 1 over sine theta, then cosecant squared theta equal 1 over sine squared theta. We will replace 1 over sine squared theta by cosecant squared theta. It will be 1/4 antiderivative of cosecant squared theta d theta. And it's equal to minus 1 over 4 cotan theta plus c, because the antiderivative of cosecant squared theta d theta equal minus cotan theta plus c. Now, in the right triangle, the opposite side of theta is x and the hypotenuse is a, and a equal 2. And by using Pythagorean theorem, the adjacent will be the square root of 4 minus x squared. Now, cotan theta equal the adjacent over the hypotenuse, means that the cotan theta equal square root of 4 minus x squared over x. Now, replace cotan theta by the square root of 4 minus x squared over x. We will get minus 1/4 times the square root of 4 minus x squared over x plus c. Let us take another example. Now, in this example, how can we find the antiderivative of x cubed over square root of 16 minus x squared? We notice here that the square root of 16 minus x squared is in the form square root of a squared minus x squared, and if a squared equals 16, then a equal 4. Then we will use the substitution x equal a sine theta, and because a equal 4, our substitution will be x equal 4 sine theta. Now we will remove all reference of x to reference of theta, and to find dx, we will derivative the both side of this equation, and we will get dx equal 4 cosine theta d theta. Now, we want to find x cubed and x squared. If x equal 4 sine theta, then x cubed equal 4 sine theta cubed. It means that x cubed equals 64 sine cubed theta, and x squared equal 4 sine theta squared, means that x squared equals 16 sine squared theta. Now, we will replace x cubed by 64 sine cubed theta and dx by 4 cosine theta d theta, and x squared by 16 sine squared theta. Now, the antiderivative here, we will take the 16 inside the square root as a common factor. We will get the antiderivative of 216 sine cubed theta cosine theta over square root of 16 multiplied by 1 minus sine squared theta d theta, and 216 we get it from 64 times 4. Now, 1 sine squared theta equal cosine squared theta. We will replace 1 minus sine squared theta by cosine squared theta. Now, we will get the antiderivative of 216 sine cubed theta cosine theta over the square root of 16 cosine squared theta. And the square root of 16 cosine squared theta equal 4 cosine theta. Simplify now. We will get cosine theta, cancel cosine theta with cosine theta, and 216 over 4, it will be 64. it will be the antiderivative of 64 sine cubed theta d theta. How can we antiderivative this? We will use that 64 antiderivative of sine squared theta times sine theta d theta. Now, sine squared theta, we will replace it by 1 minus cosine squared theta. It will be 64 antiderivative of 1 minus cosine squared theta times sine theta d theta. Now, how can we antiderivative this integral? We will use the substitution u equal cosine theta and du equal minus sine theta d theta. It means that minus du equals sine theta d theta. Now we will replace cosine theta by u. It will be 1 minus u square, and replace sine theta d theta by minus du. It will be minus 64 antiderivative of 1 minus u squared du. Now minus 64 times, now the antiderivative of 1, it will be u, and the antiderivative of u square, it will be u cubed over 3 plus c. Now if u equal cosine theta, then the antiderivative will be minus 64 cosine theta, replace u by cosine theta, and u cubed, it will be cosine cubed theta over 3 plus c. Now in the right triangle, theta is the angle here, then the opposite side is x and the hypotenuse is 4, and by Pythagorean theorem the adjacent will be the square root of 16 minus x squared. Now cosine theta equal the adjacent over the hypotenuse. It means that cosine theta equal the square root of 16 minus x squared over 4. Now replace cosine theta by the value of cosine theta. It will be minus 64 times the square root of 16 minus x squared over 4 minus 1 over 3 cosine cubed theta. We will replace it by the square root of 16 minus x cubed over 4 cubed. Now plus c. Now use the distributive property. Minus 64 times the square root of 16 minus x squared over 4 will be minus 16 square root of 16 minus x squared plus 1 over 3 times the radical of 16 minus x squared cubed plus c. I hope that this tutorial will be useful for you. See you in another tutorial. See you again, and if you like this tutorial, please subscribe in our channel, and see you again. Thank you.